Small software projects are usually beautiful and easy to read. But as a project grows, it often turns into a messy web of confusing code. Engineers have a funny name for this. They call it a big ball of mud. When code becomes a big ball of mud, it is very hard to fix bugs, and developers become scared to make changes. This makes maintaining the software very expensive. There are two types of difficulty in coding. Sometimes a math problem is naturally hard, but other times, the code is only hard to read because the original programmer wrote it poorly. We call this accidental complexity. Our goal as engineers is to completely remove accidental complexity. The absolute best tool we have to remove confusing code is called abstraction. Think about driving a car. You know how to use the steering wheel and the gas pedal. You do not need to know how the engine injects fuel or how the transmission gears spin. The steering wheel is an abstraction. It gives you a simple interface and hides all the complicated, ugly machinery underneath. Look at the diagram on the screen for a software example. When you write a simple SQL query to fetch a user, that is a clean abstraction. That one simple line of code hides massive complexity. Underneath, the database is actually scanning hard drives, managing computer memory, and writing crash recovery logs. Because the database hides that complexity, your life as a developer is much simpler. This leads us to the final part of maintainability, which is evolvability. In the real world, your boss will always change their mind. Users will ask for new features. Laws will change. And your traffic will grow. Your system requirements will never stay the same. Evolvability means designing your system so it is highly flexible and can easily adapt to these changes. You might have heard of agile programming, where developers change a few lines of code quickly. Evolvability is taking that agile idea and applying it to a massive, global scale. It means being able to safely swap out an entire database while thousands of users are still clicking on your website. To summarize this entire foundation, we must always evaluate our systems using the three main pillars. First is reliability. We know that hard drives will crash, bugs will happen, and humans will make mistakes. We build fault tolerance into our system so it survives these errors without the user ever noticing. Second is scalability. When our app suddenly becomes famous, we need a clear strategy to add more computers to handle the load. We measure this load carefully, and we look at the high percentiles to make sure our most important users are not experiencing slow response times. And third is maintainability. We use good abstractions to keep our code simple. We give our operations team clear dashboards, and we keep the architecture flexible, so our code never turns into a legacy nightmare. When we combine these three pillars, we stop acting like basic coders, and we become true data system designers.